Today we're going to talk about one of the biggest problems in finishing, and it's orange peel. So let's talk about the problem of orange peel. Our customers are getting more and more sophisticated. They're looking for this. And unfortunately, what we're giving them is this. Now, what's wrong with this picture? In the first place, the orange peel is obvious. But more than that, this is on television. And this is in an advertisement that we're telling people about our product. And it continues on. Here's the 2013 Truck of the Year. Again, we see the orange peel, and again, this is on television. It seems that no one's exempt from this. The biggest problem here is that this is on automotive news TV. This was broadcast to thousands of industry professionals, all of whom should know that this is unacceptable. But why is orange peel unacceptable? And the answer is, it's obvious. And what I mean by that is, it's obvious to the naked eye. Anybody uneducated in the ways of paint can spot orange peel because we all know what an orange looks like. If you're going to control something, you need to be able to measure it. The original way to measure orange peel was to a visual standard. This is the ACT panel standard. 10 panels allowed us to compare visually how much orange peel was in our product. With a scale of 1 to 10, was also very dependent on light and the eye of the operator. It was judgment call. But we're engineers. This kind of subjective standard is not good enough for us. We need something more objective, the Bic wave scan. This uses laser light to measure the variations in the surface finish, and it breaks orange peel down into shortwave and long wave components. Here's long wave versus temperature, and we can see that if lower is better, and it usually is, our optimal setting for long wave performance is around 21 degrees C. Shortwave, on the other hand, looks like an inverse of the long wave, and we can see that its optimal performance is along about 23 degrees C. Something that's interesting about these two graphs is that they both cover the same 6-degree temperature range and 3 steps of wave scan. So we can take these two graphs and we can run them one over the other. And when we do that, we can see the optimal point to balance long wave and short wave is around 22 degrees C, just a little above. As we move up, we can optimize short wave by sacrificing long wave performance. And as we move down, we can optimize long wave performance, sacrificing short wave. This means that we can control the orange peel by simply controlling the temperature of the paint when we apply it. How we go about that is a subject for our next little snippet.